can do it, Manish. This is what students are very happy last time. So I files problem, that's why I was doing like this. Oh, बवासीर का इलाज नहीं कर पा रहा है.
Good morning. What students are there? Okay, very fast number increase directly 14 to 57, 60. Wow. Actually, app is not working today. So otherwise, one option was what class has to postpone in the afternoon, but afternoon will be not good for you. So that's why this option. Okay. Who will say fast last what I discussed, which question I discussed in the last? And who is not attending will share the link in the app. Anybody please say fast. I think I took Young's modulus. Young's modulus definition completed. All the points I also said about the Young's modulus, I think. Okay, question not discussed. Any question not discussed? What he said? Okay. 3 points you have written about the Young modulus. Means Young modulus is the property of the material. For the given material, it is the constant, and on increasing the temperature, it decreases. And Young modulus of the steel is maximum. And then I relate with the spring force F is equal to AY by L into delta L. Means AY by L. This formula F is equal to what? AY by L into delta L. From that I relate with the spring F is equal to K delta L. Then here equivalent force constant, we can say what? That is equal to AY by L. Up to this, I think I. Okay. So voice not clear. Okay. I am good. How are you, Aruni? The voice is clear. I think that is the problem from your side. Okay, so last this one point I said what spring force, we know that Kx, where x is the elongation or compression in the spring. Same way we can relate the elastic wire force also. Force is equal to what? AY by L delta L. This formula I said. Now here delta L is what? Change in the length, elongation. Then F is equal to K delta L. For the given wire, AY by L will be constant. Now AY by L, we can say it is the equivalent force constant for the elastic wire. That I have written. K equivalent for the elastic wire, we can say AY by L. Okay. Voice is clear. This here I check. Voice not clear. Okay, means it is a problem because most of you are facing this problem. Wait, then wait. Some problem is there, no? Voice. So now you can check. It is okay. Okay. So this is the one point I said. Okay. So another point on increasing temperature. Young's modulus elasticity property decreases by increasing the temperature. Okay, so that's why elasticity decreases, then we can say Young modulus also decreases. So if they are relating the temperature with the Young modulus, one thing for numerical problem for a given material, we will take constant. But theoretically, they are asking what is the effect on the effect of temperature on the Young modulus, then we can say it decreases on increasing the temperature. Okay. So today old students are attending the class. Why? Now one problem I am writing. Okay, now listen here. A force F required to produce some elongation in the wire, then find force required to produce same elongation in the wire of double radius, half length, if the rod, if the wire is made of same material. Okay. So already I said what if they given the data for one condition and they are asking for other, then this type of problem we can do by using by ratio. Okay. So here I gave the force F for any wire, but I'm asking the force for the another wire whose radius is double and the length is half and made of same material. So we will use this formula. Either you can use the elongation delta L is equal to what? FL upon AY, or you can, I said anyone you will learn, other we can get from that. Okay, so suppose I'm using this formula. In that what, which quantities are same? I need same elongation. Okay, same elongation. Everybody getting? Here radius given, then area I can say what? Pi. pi r square into y. Okay, so here elongation I want same. Okay, one thing. Second, pi constant. Okay, material same means y same. Now FLR square. Okay, then I can say FL upon R square is equal to constant. Now either you can do what, F1 L1 by R1 square is equal to F2 L2 by R2 square. Otherwise you can use the proportionality. F directly proportional to R square by L. F directly proportional to R square by L. Now from that also you can get the answer. So F2 by F1, that is equal to what? R2 by R1 whole square into L1 by L2. R2 by R1, radius double, means R2 by R1 is the 2. So 2 square. So F2 by F, that is equal to what? 2 square. And L2 is equal to what? L1 by 2, then 2 will go up. Then how much F2 we got? F2 is equal to 8F. Completed? Okay. Next problem. If now listen here, if wire are made from the given material and given volume and wires are kept under the same load, then the elongation delta L in the wire is proportional to. So what is the meaning of this problem? Suppose I am giving the equal amount of the, suppose I am taking copper. I am giving equal amount of copper, maybe suppose assume 50 gram of copper to everyone. Okay. And I gave the equal amount, means equal mass, same material I am giving, so we can say the volume will also be same. Okay. So if I gave the equal volume of the copper to everyone and I said everybody will make the wire from that, you will make the wire from this. Okay. So everybody will make the different wire. Somebody will make the more longer wire, then their radius will be smaller or area will be smaller. Somebody will make the thick wire, so thick wire, then length will be lesser because the ultimately volume material I gave same. Okay. So then I am saying now you make the wire, everybody make the wire. Now we have to hang the same mass, or we have to put the same load on all the wires. Okay, whatever you make. Suppose I said everybody will hang the same weight. Now how the delta L will depends upon the length. Okay, that is a problem. Okay, so here delta L, what we can say, delta L is equal to FL by AY. Okay, everybody is getting or not? Here length is the, I am asking the proportionality with the length, but I have not given any data for the area. Okay, so but one thing I gave, volume is constant. So volume I can say what, area into length. Then area what we can say, V by L. Now area I can replace with V by L. Then delta L is equal to FL, L square basically, upon Vy. Okay, now this relation I got for the delta L. Which quantities are constant, that I can eliminate. Here I cannot use the proportionality, means I cannot say delta L is directly proportional to L. Why? Because force, load is constant, load is same in all. Material same means Y same. But area I don't know. What is the area? Area is not constant. So I cannot say delta L is proportional to L. So that's why this area we have to remove. How? area we can put V by L. Now if you see this relation, then in that load is constant, volume is constant, material same, then I got the relation delta L is proportional to L square. Completed. So if I ask what is the graph between delta L and L, what will be the graph between delta L and L? What is the graph between delta L and L? Graph between delta L and L. Parabola. Parabola, why? Because suppose this I am plotting on Y, this is the X, so Y is equal to CX square. Y is equal to CX square is the parabola symmetric about Y axis. Okay. Now this graph I have given for the two wire for the different material. Okay, wire one graph is the A, other graph is the B. I am asking which material is more elastic, which material is more elastic, or I can say which material will have the more Young modulus. Okay, now listen. One thing, when you are solving any problem of the graph, see the X and Y axis first. See the Y axis and X axis, because maybe we mucked up stress here, Y axis strain here, but maybe they can reverse also. Okay, so here I gave the Y axis is the stress, X axis is the strain. Okay, then we will think the relation between them. So we know the relation, what? Stress is equal to Y into strain. Okay, so stress is equal to Y into strain. Okay, stress I am plotting on Y axis. This Y Young modulus I am taking Ym. Otherwise here you will get confused. Both will be YY. So Young modulus I am taking Ym. Stress I am plotting on Y axis, that is equal to Ym into strain I am plotting on X axis. Now Y is equal to Mx. Y is equal to Mx, that is a straight line passing through origin, and that graph only given. It means here Ym represent the slope. So I can say the slope of the line is Young modulus. Now slope more, Young modulus more. Young modulus more, elasticity is more. Then I can say Ya is greater than Yb. So A is more elastic. A is more elastic. Completed. Okay. So wires are made of same material and all have same radius. Then order of length. So here I gave the three graph for the three different wire, and all the wire are made of the same material and they have the same radius. I'm asking what is the order of the length for the wire A, B and C. Okay. Now here again we are getting the graph is a straight line, but what I plotted on Y axis load and what I plotted on X axis elongation. Then load means force. So force formula is what? F is equal to A Y by L into delta L. This is a force formula. Okay. I'm using the radius, so area I can replace with pi r square. So F is equal to pi r square y by L into delta L. Now load I am plotting on y axis, and elongation, load means what? Force, weight. Then force I can replace with y, delta L I can replace with x. Okay. Then y is equal to pi r square y by L into x. Now in the place of slope, what we have? Slope is the pi r square y by L. So slope is what? Pi r square y by L. And radius I gave same, material I gave same, so numerator is same. Then I can say what? Slope is inversely proportional to L. Slope is inversely proportional to L means whose slope is lesser, its length will be maximum. Okay, now what is our order? C slope is minimum, then C will be longest. So order of the length I can say LC greater than LB greater than LA. Okay. Completed. Okay. So here two wire of the different material. One wire has the Young modulus Y1, other wire has the Young modulus Y2. Okay, and I'm hanging okay, I connected end to end, and then I hang the mass M from this from the second wire. Okay, area I gave same. Now first question I'm asking, I'm giving the option, you will say the answer. Stress in both wire will be same, one option. Second option, stress in both wire will be different. Okay, first decide that. I'm asking, stress in both wire will be equal. Second option, stress in both wire will be different. Third option, can't determine. Stress in both wire is equal, stress in both wire is different, or can't determine means data is insufficient. Tell fast. Different. Listen, this property we have learned. Like suppose in the series combination, the spring also we will use that. When you are connecting, like you are making the line and you are holding each other. Suppose somebody first in the there is a queue. In that, first person is holding something, or suppose wall they fix at some point. Okay. Now others are pulling. Okay, but they are not going anywhere. So between the two person, action reaction pair will be there. Like in the rail train, between the two compartment they are connected. Okay. So how much force the one compartment is applying on the other? So same will apply by the other compartment, because action reaction pair. So action reaction will be equal and opposite. Okay. Here one thing, I have not given the mass of the string. It means the string we have to consider massless. So in the Newton's law you learned, when the string is massless, tension will be same everywhere. Okay. Yes or no? If this case, if I'm taking the string is massless, if it has a mass, so already I discussed the stress one last class. When rope has the mass, then different point will have the different tension. Okay, but here tension will be same in this wire. Okay, now these white and green wire, they connected each other in the series. So how much force the green wire will apply on the white wire, like this pulling? So by from the reaction, we can say from the action reaction, white will also apply the same force, and that force is what? Basically tension. It means tension in both wire will be equal. When they connected in series, it means tension in the both will be equal. Tension equal, area I gave equal. So what is the stress? Stress is the tension upon area or force upon area. then stress will be same in both wire. Everybody got or not? Okay, this everybody got. So it means stress in the wire 1 will be equal to the, if I gave the area different, then stress will be different, but the force will be same. This everybody got or not? And if the wires are massive, if the wire has some weight, they given the wires weight, then in the same wire only, even tension will be different at the different point. Okay, this everybody understood or not? Tell fast. Okay, now second thing. Now second option I am giving. Strain in both wire will be equal. First option. Second option, strain in both wire will be different. Next problem I am asking, strain in both wire will be same. Strain in both wire will be different. Tell fast. Strain in both wire will be different. Strain in both wire will be same. Different. Strain will be different because stress is equal to Y into strain. I am using the different material. Different material, stress is same, but material is different, then strain will be different. If I am taking the material same, then strain will be same. Okay. So I can say what here? Strain is equal to what? Strain is, or stress is Y into strain. Then stress same, then Y and strain will be, Y is different, then strain will be different. Okay, what about delta L? Anybody can say what is the, can you say something about the change in length? Means change in length, delta L1 will be more or delta L2 will be more or both will be equal? We cannot say anything. Reason is what? Here I gave the length is different. So L1 and L2 are different. Strain is different. Means delta L1 upon L1 is equal to delta L2 upon L2. Okay. It is possible that we cannot determine. Means here we need the some another data, means Y relation and all we have to find, then only we can relate. Otherwise directly we cannot say the elongation will be same or different because length has given different. If I have given the length same, if the length I have given same, then I can say delta L will be different. Delta L will be different. Why? Because the strain is different. Strain is what? Delta L by original length, change in length upon original length. If I gave L1 and L2 equal, if L1 and L2 are equal, then delta L1 must be different from the delta L2 because the strain is different. But here length I gave different, then I cannot say anything. Everybody got or not? Number 3, if I am asking what is the total elongation? What is the total elongation? So delta L total, that will be equal to what? Delta L1 plus delta L2. In the NCERT, this question only given. So they given the numerical value, Y and all. I am using the symbol. They have given the numerical value. So delta L total is equal to what? Delta L1 plus delta L2. Now, what is the delta L1? Delta L formula is the FL upon AY. So tension will be mg L1 upon A Y1. Second, I can say mg L2 upon A Y2. Then if further you want to simplify, so mg upon A you can take common, then L1 by Y1 plus L2 by Y2. Everybody got? So this is the total elongation. Okay. So in this problem, one string I have taken. and from that one end of the string is suspended at the rigid like on the roof, and the other free end we have connected the mass M. Okay, that is the first case. Second case, same string I took, and then I pass over the pulley. That string is passing over the pulley, and both side I hang the mass M. Okay. Now here, if in this case elongation in the string is the delta L, in the first case elongation is the delta L, I am asking what is the elongation in the second case. Same string I took, I am asking the elongation in the second case. L fast. If first case elongation I gave the delta L, then what is the elongation in the second case? Same. So if I'm asking what is the tension here, so tension I can say here what? T and then mg. So tension is balancing the weight of this block. So we can say here what? T is equal to mg. Then delta L, what I will write? mgl upon 2ay. mgl upon ay. Okay. So here I will get the delta L is equal to FL. FL means mgl upon ay. Okay. Now come to this second. If second case I am asking what is the tension in the string, so somebody is saying 2 delta L because they are taking the tension double. Ultimately tension what? Tension is acting up and both side equal masses means system will not move. No acceleration is there. Then I can say T is equal to what? Mg. So here also what I am getting? T is equal to mg. Now same wire I am taking, so natural length, area, everything will be same. So delta L2 what I can say? Mg L upon A into Y, that will be equal to delta L. The only difference, what is the difference here? Here I am suspending the two masses. Here I am suspending the one mass. So, but ultimately situation is same. Why? Because here it is tied at the roof. So what the roof is doing, roof is also applying that pulling tension on the string. Where? Upward. Okay. So if I see the string force, so string force, block is applying down. How much? T. Okay. And roof is applying the force because a rope is pulling the roof down. So what the roof will do, it will apply the reaction of that upward. So on the string, force is like this, T and T. Okay. And last class I discussed net force is 0, but here we will get the restoring force is equal to what? T. So, and what is the T? Mg. So here we got the tension is equal to mg. In this case, I'm not suspending the string from the roof. Here, what I did, I suspend the mm mass on the both side. Okay. Now ultimately the situation same. If you are taking the mass m here, now again this mass m is applying the tension on the string mg down. Okay. And this mass is m is also applying the mg down. So ultimately in the string net force is what? Same situation is there or not? Mg in the opposite direction. So in this case also tension is what? Mg. Now tension same, string same, then elongation will be same. Then we will get the delta L2 is also what? Delta L. Completed? Okay. A simple problem, M1. What is the elongation in the string 1? What is the elongation in the string 2? Elongation in the string 1, elongation in the string 2. Elongation in the string 1, elongation in the string 2. Now, string 1, what is the tension in the string 1? We can see like this. This whole weight is suspended. Okay. Then T1 I can say what? M1 plus M2 into G. Okay. And what is the T2 I can say? T2 will be equal to this weight. Last class I gave the example. Means whatever the weight is hanging below that point, according to that we will decide the tension. Here from this string M2 is hanging. So then we can say T2 is equal to what? M2G. Now you have the tension. You can find the elongation. Delta L1 is equal to FL upon AY. It means what? M1 plus M2 G into L is what? L1 upon A1 into Y1. Similarly, delta L2, what I can say? M2G into L2 by A2 into Y2. Completed. That data I gave exactly, I don't know what is the Y's U. So I gave the Y of the copper is 1.2 into 10 to the power 11, and Y steel I gave what 2 into 10 to the power 11 Pascal. And what is this situation? Two identical copper wire, and one steel wire we have taken, and one block we suspended at the free end. Okay. Everybody got? So 3 wires are there. From that we suspend the one block of mass M. Now what I'm saying, if tension in all the 3 wires are equal, then ratio of radius of copper and steel. Okay, so what I said, if the tension in all the 3 wires are equal, then we have to find the ratio of the radius of the copper and the steel wire. Okay, so if you see the situation, so here all the 3 wire we have the same tension. Okay, they have given all the 3 wire we have the same tension. Okay, now I'm asking the ratio of radius, so I can go to the, again, only one formula is there in this chapter we have up to now. Delta L is equal to what? FL upon AY. That A I can write as what? Pi R square into Y. Now listen, which quantities are same in that? They are asking the ratio of the radius, okay? So here, what I gave, tension is same in all the 3, okay? Force is same, okay? Next, pi constant, no need to think about the pi. To hang the block like horizontally, initial length of all the 3 are same, so L is also what? Same. Okay, in parallel combination, what will happen? Suppose this block is suspended, then after elongation also it will be horizontal, then it means what? Elongation in all the 3 will be also equal, then delta L also equal, because ultimately after elongation it will be like this. Then delta L also we can say what? Same. Now delta L same, F same, L same, pi constant, then I can say what? R square Y is equal to constant. Now R is inversely proportional to root Y. Then R copper upon R steel is equal to under root of Y steel upon Y copper. From that we will get the answer. So R copper, R Cu upon R steel is equal to under root of Y steel upon Y copper. Now put the values, you will get the answer. Completed. Okay. So here what I gave, one cubical block, its density I gave what? Rho, and the length I gave what? L. Now that cubical block is moving with an acceleration A. That is not our matter, means how it got the acceleration A. Okay, so cubical block is moving with an acceleration a. Now I am asking what is the stress? What is the stress at the mid section of the square? Means at the mid of the cube. At the mid of the cube, what is the stress? Okay. So ultimately stress is what? Internal force per unit area. Here, which force will be internal tension? In the Newton's law, this type of question you have done when we have the rod or the massive rope and we are pulling this by suppose force F. Then what is the tension at a distance x from the free end? What is the tension at the distance x from the this end? So what we are doing, we are separating the rope in the two part and we are making the free body. This type of question you have done in the Newton's law. Okay, here I am asking the stress at the mid portion. Okay, so I will find the first, we have to find the tension here. Suppose tension I am taking T. Okay, now this cubical block I can separate into the two part, this and this. Okay, this part who is giving the acceleration? For this, if I am writing the force relation, so for this portion, force relation will be what? P is equal to m by 2 into a. M by 2 into a. Why m by 2? Because for this, how much mass is this side? M by 2, because I am asking at the mid portion. So I can say T is equal to m by 2 into a. This everybody got or not? Now that tension upon area will be the stress at the mid portion. Now mass I have not given, then what we will do? T is equal to mass, I can say volume into density. Volume of the cube is L cube, density I gave rho. Okay, this is the mass, volume into density into A by 2. Okay, L square, area is equal to what? Area is equal to L square. Cross sectional area of the cube will be what? L square. So L square you can shift down. So T by L square, that is equal to T by A. What I will get? Rho L A by 2. So what is the stress at the mid portion? Rho L A by 2. Everybody got? Tell fast. Now listen, here one wire of the length 12 we fix between the rigid wall. Okay, length is what? 12. Now at the midpoint, I suspend the mass M. Okay, after suspending the weight go due to the weight, the this string got what? This point got sink by X. Okay, everybody is getting this type of question we have done in the Newton's law. When we connected the mass M here, it got sink, okay, by X. And one thing in the solid wire when we are considering, so this X will not be very large. Okay, so means elongation will not be like not a rubber wire, it will start oscillating. It is a metal wire, we can say, so then it will sink, but it will sink lesser amount. Or I can say X is very small in comparison to L. So maybe they will give data they are not giving, then we have to take what? Elongation will be not very large. That's why X will be very small in comparison to L. Okay. Now I'm asking find the strain in the wire. So answer I have to give in the terms of the L and X. We have to find the strain. Okay. Everybody got the problem or not? So one wire of the length 12, I fix between the two rigid wall. Now we suspend the one weight at the midpoint of the wire. So midpoint got sink by the, or it fall down by the X distance. It come down by the distance X. Okay. Then I have to find the strain in the wire. Okay. Now strain is what? Change in length upon original length. Sorry. Okay. That this time whole campus is the cold infection is there. That is the one problem with our offline. So when the students are coming for the doubt, you will also get infected. Okay, so find strain in the wire. So strain means change in length upon original length. So first I am saying what is the change in length? Delta L. Okay. So what is the new length? I can say new length is what? This is the new length. White is the initial length. White is the initial length. Okay. So this length, how I can find? This is the hypotenuse. Hypotenuse I can say under root of L square plus X square. Okay. After, wearing the mask is also the big problem. In the COVID time, so many people died due to them wearing the mask also, na? Because mask means then you cannot breathe properly. No? You will not get the oxygen because N20, somebody was wearing the 2-3 N20 mask that time, N20 this. Reusable. Okay, so what is the delta L? Delta L means change in length, means final length is this is what? Under root of L square plus X square, and it is a double of that, so I will take what? 2 under root of L square plus X square. Okay, this is the final length. Okay, minus initial length. What is the initial length? 2L. So this is the delta L. This everybody got or not? Now delta L I can say what? Here L square plus X square is there, and L is X is very small in comparison to the L. Okay, I want to go to the binomial because this condition when it will come X is less than L, and this, so we have to think the binomial can I use because here root is there. If I am taking L square common from here, so L square, then what will come out of the root? L. Okay, so then 2L under root of 1 plus X square by L square. I took L square common, but out of the root L will come, minus 2L. Up to this everybody got. Now delta L is equal to 2L take common, then inside the in the bracket what I will get? 1 plus X square by L square whole to the power 1 by 2 minus 1. Okay, this step everybody got. Under root I write as a power 1 by 2. Now you can see this 1 plus X. In the place of X I have X square by L square. In the place of X we have X square by L square, and X square by L square is very small in comparison to 1 because this data we have X is small in elongation will not be very large. So X is very small in comparison to L. So X square by L square will be less than 1. So 1 plus X to the power N, we can use the approximation 1 plus NX. Okay. So delta L, what I can say? Delta L is equal to 2L into 1 plus NX. NX means X square by 2L square minus 1. 1 and 1 get cancelled out. Now who will say what is the strain? Tell fast. What is the strain now? Everything I did, at least one last answer you can say. What is the strain? What is the strain? X square by L. Okay, one answer I got. X square by L. Okay, deleted. I tell fast. X square by L. Okay, X square by L. What Tanuj is saying? X square by L square. Okay, X square by L square. 2X square by L square. Okay, all permutation combination will be there. Somebody will say 2 in the numerator, somebody will say 2 in the denominator, somebody will say without 2, X square by L. Okay. Somebody saying X square by 2L square, X square by 2L square. Okay. Now listen, that up to this you will do correct. But what will happen in the last, we will forget one thing. You have done, but in the beginning, what is the length? Strain is what? Change in length upon original length. So most of you, what they are doing, they are taking delta L because you mucked up the formula. Delta L by L is the strain. basic, you don't know what is a strain means? Strain is the change in length upon original length, not the delta L by L. What is the original length here? 2L. So what is the strain here? Delta L by 2L. Here strain is what? Delta L by 2L. Are you getting or not? So here is strain, what we will say? So strain is equal to change in length. Change in length is what? Delta L. And what is the original length? 2L. So this value will come what? X square by 2L square. X square by 2L square. Everybody got? So delta L by L means you close the eyes and without thinking anything, you are applying the formula, and that is happening. Most of the chapter you are doing this. Formula only you are making, you don't know what is the basic meaning and what is the basic definition of the quantities. So strain is what here? Change in length upon original length. Here original length from the beginning we have taken what? 2L. So that's why we have to find the delta L by 2L. Okay. Now listen, suppose one cylindrical rod, okay, I fix on the roof, okay, and this is the cylindrical rod. Now we are giving the twist. This we have tried in our childhood also. Suppose this is the rod I fixed on the roof, and then I am giving the twist. Twist means like this, I am rotating, okay. Like in the curtain, you wrap yourself, and then when you pull your leg up, then we were unwinding. It is an example of the torsional pendulum, and I think most of us we have done that. Okay, so here one cylinder we have that I fixed on the roof. Other end is free. That end, what we are doing, we are twisting it by some angle. Okay, at the bottom I am twisting by some angle. I am asking what is the shear strain. Find shear strain in the everybody got? So just like this bottle I fix at the top, and this bottom I am twisting by some angle. Okay, so then why shear strain will be there? So in the when I explain the shear strain, I fix the cube and on the base, and I apply the tangential force. So the shear strain, what I said, shear strain is the ratio of the displacement of the face to the perpendicular distance between the opposite faces. If you remember the formula that I said, X by L. Okay. Here we are not, basically we are applying the force, but basically it is a rotation effect. It has the rotation effect. Okay. So just imagine the one line on the bottle, and when I twist it, then what will happen? Suppose any point is on the base. Okay. When I twist it by an angle theta, so that point will also get what? Displaced by theta or rotated by theta. Again, I'm repeating, if I twist at the bottom, just imagine one line on the cylinder like this. Okay. When I rotate at the bottom by theta, so the point on the base is also rotated by theta. Okay. So what is the displacement of circle? What is the displacement of the bottom circle? This point got rotated by theta, means how much distance it cover? Arc length. Arc length is equal to what? Angle into radius. Like suppose this circle, any point you are considering on the circle, and when you rotated this circle by theta, so this point came here, so this is the distance traveled by this. Okay, that is basically what you can take X. So the point is on the circle, when I rotate by theta, point also move by theta. Then how much displacement is there? Displacement will be equal to the arc length. What is the arc? Arc is equal to angle into radius. So here X I can say what? R into theta, where theta is the twist angle. Okay. Now X is the R theta. Okay. Now what is the perpendicular side? Here and here. Perpendicular side, what you will take? Opposite faces. That is the what? Length of the rod. Then what is the shear strain in that? X by L means I can say R theta by L. And directly if you want, then you can remember this relation also. Then shear angle So shear angle phi, what I can say, phi is equal to r theta by L. R theta by L. It is a relation between the shear angle and the angle of twist. Everybody got or not? Now, according to the data given, we can use. So this relation, if you want, then you can remember r theta by L is equal to shear angle phi for this rod type rotation. Okay. Now, phi I am asking. R I gave what? 10 centimeter means 0.1 meter. Theta, if the answer they given, the options they given in degree, then directly theta you can put here degree. Option you will answer, you will get in degree. So this I gave what? 2 degree. And what is the L I gave? L is the 10 meter. Now then I got what? 0.1 means 2 by 100. So phi what I got? 2 in 0.02 degree. Everybody got? If option they given in radians, then you will multiply with pi by 180. Okay. Are you completed? Okay. Okay, then next problem. If tension So here what I gave, one wire has the tension what? 5 Newton, then its length is L1. When the tension in the wire is 8 Newton, then the length is L2. Now I am asking what is the length of the wire when the tension is 10 Newton. Okay. Everybody got or not? Okay. Now here this length L1, L2 what I gave, it is not the natural length. Why? Because it is under the tension. When we are applying the 5 Newton tension, then we are getting the length is L1. It means it is a okay. So what I said, if we are applying the tension, then we have the length what? L1, 5 Newton tension. When the tension is the 8 Newton, then the length is what? Then the length is L2. Now I'm asking what is the length when the tension is 10 Newton. Okay. Now what we can do here, I have not given the natural length. So suppose I am taking the natural length of the wire is L. Okay. Or L0 I am writing. So natural length I took the L0. Okay. So when the length is L1 and natural length is L1 and the natural length is L0, then what is the elongation? Elongation will be L1 minus elongation will be L1 minus L0. Elongation will be L1 minus L0. Okay. Then delta L1 what I can say, L1 minus L0. That is the elongation because L1 is the elongated length. L1 is elongated length, then the natural length what I took L0, then what is the elongation I can say L1 minus L0. Everybody has to focus the class. There is a what? That is the problem with the online, means the some unwanted people also comes. So we have to ignore, it is better. Okay. Okay, so delta L1 what I can say L1 minus L0. Okay. Similarly, delta L2 what I can say delta L2 will be equal to L2 minus L0. And suppose I am saying third case, when the tension is 10 Newton, suppose I am taking the length is L3. Tension is 10 Newton, the length is L3. So delta L3 I can say what? L3 minus L0. This L3 I have to find. Everybody got? So L3 we have to calculate in the terms of the L1 and L2. Okay, now listen. I am taking the same wire. Okay, I'm taking same wire. This L3 we have to calculate. Okay, same wire means if I'm saying the delta L relation, so delta L is the FL upon AY. For same wire means its natural length, Young modulus, and area will be constant. So for the given wire, delta L is directly proportional to F. Delta L is directly proportional to F. Now, delta L1, first case. Delta L1 means L1 minus L0. I can say directly proportional to 5 Newton because tension is 5 Newton. Then the length is L1. Everybody getting or not? But proportionality, if you want, then you can remove my proportionality constant. That is, I'm taking C. C is the proportionality constant. That value will be basically L by AY. I'm taking as a C. So L1 minus L0, what I can say? 5C. C is the constant. Okay. L2 minus L0, what I can say? That is equal to what? 8C. It is a 2. And then L3 minus L0. L3 minus L0 will be equal to what? 10C. That is a 3. Now listen, if they need the natural length, then they will not give these 3 data. Okay, 2 only sufficient for the natural length. If they need the natural length of the wire, they will give only first 2 data. Okay, then after dividing, C and C will get cancelled out. Directly I will get the L0. So if they need the natural length, so then by dividing 1 and 2, we will get the L0 in the terms of L1 and L2. Okay. Everybody got or not? So then they will not give all these data. If the natural length required, so then 2 data is sufficient. But they need the L3. Here then they are not asking natural length. They are asking the length when the tension is 10 Newton. It means we need L3. Okay. So somebody will do what? By using the 1 and 2, they will find L0. By using 1 and 2, you will find L0. That L0 you will put here. Okay. And then still you cannot get the L3. Why? Here 10C is there. So that again you will divide either 2 and 3 or 1 and 3, then C and C will get cancelled out. So what I'm saying, if you need L3, what you will do? By dividing these 2, you will get the L0. After solving L0, you will put here. That L0 you will get in the terms of C. This relation again you will divide either 2 and 3 or 1 and 2. But that will be lengthy. I don't require L0. In the question they don't ask L0. Then why necessary I will find the L0? So after this, if I need the L0, what we will do? Subtract 2 and 1. So if I subtract, then I will get what? L2 minus L1. That is equal to 8C minus 5C. That is equal to 3C. Okay. And subtract 3 and 2. Then what you will get? L3 minus L2. That is equal to what? 10C minus 8C. That is equal to 2C. Okay. So you got one relation. L2 minus L1 is the 3C. L3 minus L2 is the 2C. In that L0 is not there. And I don't need L0. So now after dividing this directly, you will get the L3. So now L3 minus L2 by L2 minus L1 is equal to 2C by 3C. CC cancel out. Cross multiply. You will get the L3. So I think it will come 2L2 and then 5L2 minus 2L1. So L3 will be equal to what? 5L2 minus 2L1 by 3. Everybody got or not? So natural length required, then only first and second relation is sufficient, but the L3 they are asking, so no need to calculate the L0. Okay. So maybe 10, 15, 20 minutes will lag because class started late today. So that I will see in the next class. Otherwise, accordingly, we will plan. Okay. Okay, then bye-bye. No worries.
तुम्हें क्या पूरी पूरी खिलाएं?
आवाज ही नहीं